class is mainly for the beginners to understand two key concepts. There's what we call descriptive statistics for ungrouped data and grouped data. So before we go any further, we're going to first look at what are called pictograms. Pictograms are important for data presentation. This is going to be important for most of you who will be doing your final research to doing presentations. So you need to know at least what each of these pictures are. So we have pictograms 1 to 6, where 1 is a bar chart, 2 is a histogram, 3 is a cumulative frequency graph. It accumulates, it goes up. 4 is a relative frequency graph, it fluctuates. 5 is a box whisker diagram, and 6 is a pie chart. The difference between a bar graph and a histogram is that the bar has gaps in between, where the histogram is attached. So for a bar graph, you can have 1 to 5, 6 to 10, 11 to 15, because there's a gap between 5 and 6. But if you had the same frequency, 1 to 5, then here you start from 5 to 10, and here you start from 10 to 15. So this becomes a what? A histogram, because where 1 ends, that's a starting point for the other. So you can convert a batch graph data to a histogram by adding a 0.5 on the upper bound and subtracting a 0.5 on the lower bound. Now we'll talk about this later on in depth. So we're now going to look at what we call ungrouped data. So we're going to be given data sets, for instance, 1, 2, 2, 4, 4, 6, and 8. So we're going to find all the measures of central tendency and the measures of dispersion. All the measures of central tendency and dispersion. So I'll start with the measures of dispersion. So here we have 2 times 2 is 4, 4 times 4 is 16, 4 times 4 is 16, and 6 times 6 is 36. And here we have 64. Kindly help me. The total for each of these ones is called a sum. So this is called the sum of x, the sum of x squared. So what is the sum here and what is the sum there?
$24.
Here we have 24. And here?
136.
136. Then what do we have as our n?
5.
Number of elements were 5. All right, so we'll start with what is called the range. What is a range? What is a range by definition?
It is the highest value minus the lowest value.
The highest value minus the lowest value. Okay, that is the range. So it's simply an area of variation between an upper and a lower limit by definition, so literal. It's the set of the difference between two specified limits. That is a range. So it has given us a formula. It is the highest number of x minus the lowest number of x. What is our highest number of x? Eight. And what is the lowest number of x? We have 2. So our range becomes 6. We have another parameter called the mode. What is a mode?
Number of highest frequency.
Okay, the highest frequency, good. the number that appears the most. Which one is our highest frequency here?
4.
4. So if we had 2 4s and 2 6s, it becomes a bimodal frequency. So we could say 4 and 6. What I'm trying to say, it could have more than one mode. It's okay. All right. So we now move to what is called the quartiles. So we have 3 quartiles. We have Q1, which is a quarter. We have Q2, which is half. And we have Q3, which is 3 quarters. So for ungrouped data, we always amount it to n plus 1. So let's start with Q1. Q1 is called the lower quartile. What is a quarter of n plus 1? And our n in this case is what? 5. So 5 plus 1 is 6. What is a quarter of 6? I need you to have the calculator nearby. What is a quarter of?
1.5.
1.5. Good. So 1.5. Whenever you have a 0.5, it means you are doing what? You're adding that prevailing number. For instance, let me look at 2, for instance. 2.5, you're looking at the second number, the number which is appearing in the next one. The third number, you divide by what? By 2. If you're looking at 2.25, you round off to the nearest whole number, which is what? 2. If you're looking at 2.75, you're rounding off to the nearest whole number, which is what? 3. All right, so in this case, 1.5, what are we looking at? The first number and the second number, right? Then you divide by what? By 2. So our first number is what? 2. Our second number is what? 4. The position is 1.5, but the actual answer is 3. So this is our first quartile. Our second quartile is Q2. It is half of what? N plus 1. Our N is what? 5. 5 plus 1 is 6. So half of 6 is 3. So which one is the third number? Which one is the third position? So 1, 2, 3, 4, 5. Our third position is 4. So 4 is our second quartile. Then we go to the third quartile, which is 3 quarters of n plus 1. So n plus 1 is 6. 3 quarters of 6, what do we find? 4.5. So what does that mean? 4.5 means the fourth and the fifth. Then you divide by what? By 2. So the fourth is 6 and the fifth is 8. You divide by 2. What we get is a what? The 7. So this is how we find the quartiles. Any questions before I proceed?
Yeah, just on the first quartile.
Yes, please.
Yeah, how did you select the first and the second number? First and second.
So whenever you find a 0.5, you get the prevailing number and the second number. So a quarter of 6, we found 1.5. So 1.5, we get the first and the second number. If we found 2.5, the second and the third number. All right?
Okay.
Yeah.
Okay.
So the first thing you needed to do was to rearrange your data. Your data was 4, 2, 4, 6, 8. You have to rearrange it in order. So that is how you're supposed to do it. Now, we now go to what is called the interquartile range. Interquartile range is equal to Q3 minus Q1. What is Q3 and what is Q1? What is Q3 and what is Q1?
7 and 3.
Okay. Subtract the Q3 and the Q1. So that is 7 minus 3. What do we get? We get 4. Right. So that is how we find the interquartile range. Okay. Half of the interquartile range is called the semi-quartile deviation. Half of the quartile range is called the semi-quartile deviation. So SQR is half of the what? Interquartile range. So interquartile range was what? Was 4. Half of 4. What do we get? We get a 2. Then we also have what we call the correction term, the CT. Correction term is 1.5 times interquartile range. So 1.5 multiply times 4, which was interquartile range. What we get is a 6. So we have established how to find the Q1, Q2, Q3. Then our X minimum is the smallest number, and X maximum is the highest number. So now this will help us come up with what is called the box-Whisker diagram. The box-Whisker diagram or box-Whisker plot has 5 important dimensions. Is what we call the X mean, is Q1, Q2, Q3, and X max. So what was our X mean? We had 2, and the X max we had 8. So here we put a 2, here we put an 8. Then we also had Q1, Q2, Q3. So 3, 4, 7. So you put your 3, your 4, and your 7 here. So this is a box-Whisker plot. And the box-Whisker plot also, you can use a correction term to adjust for outliers. On the lower bound, you subtract the outlier, and on the Q1, you subtract the outlier, the correction term. On the Q3, you add the correction term. So on the 7, we're going to add the 6. So plus 6 will take us to what? To 13. On the 3, we'll subtract the 6, it will take us to negative what? Negative 3. Now this helps you identify the odd one out. So if we had given a frequency of 2, 4, 4, 6, 8, 17, and 20, just hypothetically, the outliers are numbers that are exceeding the 13 or below the negative 3. So in this case, we have these 2 numbers that are outside the given range. We'll call these ones outliers. That is the use of the what? box whisker diagram. So these ones are called outliers. Any questions at that point? All right. So sometimes 0, 1, 2, 3, 4, 1, 2, 3, 2, 2, 4, 5, 3, 6, 7, 7, 4, 1, 3, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 1, 2, 3, 1, 2, 1, 2, 3, 4, 5. So sometimes you'll be given 0, 2, 0, 3, 4, 4, 14, 15, 3, 26, 27, 7, 24, 27, 31, 33, and 40. So you'll be asked to draw a stem and leaf diagram. So this is how you draw the stem and leaf diagram. You identify the smallest numbers, they start with a 0. So this is called the stem, and this is called the leaf. So don't mind what I drew here. So I have to start afresh. So how do we draw the stem and leaf diagram? You identify the stems, which are the big numbers here, the front numbers. We have numbers that start with zeros, numbers that start with 1, numbers that start with 2, numbers that start with 3s and 4s. So we start 0, 1, 2, 3, and 4. So the smallest number is what? 0, 1. So put 0, 1. The 0 is already there. The second number, 0, 2. The third number, 0, 3. Put them in order. Then we have a 12, so which is 1, 2. Another 12, 1, 2. Then this is 14, 1, 4. Then we have 1, 5. On the ones, are we done? Yes. Then the twos, we have 2, 3. But here the order is not okay. We can't go to 2, 6 before we go to 2, 2, 4. So 2, 3, then we go to 2, 4. Then the next number is what? 2, 6. Then 2, 7. There's another 2, 7 here. 2, 7. Then on the threes, we have 3, 1 and 3, 3. On the fours, we have 4, 0, which is 40. Altogether on drawing the stem and leaf diagram,
Yes.
then now we want to identify the range. From what we are just from learning, how do we find the range? The highest number minus the smallest number. So high value minus what? Low value. So we have 40 minus what? Minus 0, 1, which gives us 39. Then we go to the mode. Which numbers appear the most?
Yes.
We have the 2s here and the 7s there. So this is not a 2, but a what? A 12. This is not a 7, but a what? A 27. So that is our most appearing numbers. So So we have 12 and 27. How many are there in total here? Our n is 15. So who remembers how to find the first quartile? Our Q1 is given by what? A quarter of n plus 1. And our n is 15. 15 plus 1 is 16. A quarter of 16 is 4. Then we're going to count the fourth number. Which one is the fourth number? Since I already arranged in order. 1, 2, 3, 4. What number is this? That is 12. We go to our second quartile. Our second quartile is half of n plus 1. And our n is 15 plus 1, 16. Half of 16 is the 8th number. So let's count the 8th number. 1, 2, 3, 4, 5, 6, 7, 8. What number is this? 23. Then we go to the third quartile, which is 3 quarters of n plus 1. So our n is 15. 3 quarters of 16 is 12. The fourth number, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We can't fix this because they're not arranged. Go here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12, coincidentally, it's the same, but you use the most accurate, which is what? The stem and leaf diagram. So who remembers how to find the interquartile range? Anyone?
Q3 minus Q1.
Good. Q3 minus Q1. And what is our Q3?
It's 27.
And Q1?
12.
And what do we get?
15.
15. Who can find the semi-quartile deviation? It's half of the interquartile range. So half of the 15,
Yes.
which is what? 7.5. And the correction term is 1.5 times 1.5 times 15. What do we get? 1.5 times the interquartile range. What are you getting? It's 2.5. Is it? So what 3 things do I need to come up with the box-Whisker diagram? Who remembers? Number 1?
X max.
X mean. Number 2?
Q1.
Number 3?
That's Q2. And the max.
X max. Good. So what is our X mean? Zero 1 and X max 40.
That's 0, 1.
And what is our Q1? 12, 23, 27. 12, 23, 27. Then how do we find the outliers? The extreme values. We add 22 point what? 22.5. What does it give us? 47.5. When we subtract from here 22.5, what do we get?
49.5.
Negative. So do we have any outliers? No, because everything is within. We have no outliers. right. Then we go to finding the mean, the variance, and the standard deviation. So we have 2, 4, 6, 8. So this is 4, 16, 36, and 64. All right. I left another 4 here. 16. So what was the total we found here? Summation of x was what? What did we find? 24 and 136. 24 and 136. Who remembers how do we find the mean? The mean?
It's the middle number.
Average, yes. Not the middle number, but the average. It's summation of x over n. So 24 divided by 5, what do we get? What do we get? 4.8. Then the variance, the formula is given by summation of x to the power 2 over n, everything over n minus 1. So here we have 136 minus 24 squared to the power over 5, everything over 5 minus 1. So what do I get from there? We start from here. 24 squared divided by 5. The first square divided by 5, we're going to get 115.2. 115.2. Then you divide this by 4 when you get the difference. So we do 136 minus 115.2. The answer I get is 20.8. Divide by 4. What do we get?
5.2.
5.2. Good. So this is called our variance. So the standard deviation is when you square root the variance. The square root of 5.2. What do we get?
2.28. 28.
All right. At this point, anyone behind? So these are formulas you just need to know by heart. Please, this is a beginner's class. I need you to take note of these important formulas. Then we go to what is called the coefficient of variation. Coefficient of variation. So the coefficient of variation is given by the mean over the standard deviation over the mean times 100. So our standard deviation is 2.280 divided by 2.288 divided by the mean of 4.8 times 100. What do we get?
47.5. 501.
Good. 47.507%. Finally, find what is called the coefficient of skewness. It is given by 3 mean minus median over standard deviation. 3 mean minus median over standard deviation. So our median was found, our mean 4.8, our median, we found it as what? The median was Q2. We found our 4 here. If the median is wrong, you're also going to get it wrong here. 4. And our standard deviation is 2.28. So what do we get? We get a positive 0. What? It's 1.05. Okay, 4.8. 4.8 minus 4, 0.8. 0.8 times 3, 2.4. 2.4 divided by 2.28, get 1.05. Here, you just come into that's positively skewed or negatively skewed. We end here. When if you get a negative, you say it's negatively skewed, it means bending to the left. Get a positive, it means it's tilting to the right. So this is the end of our beginners class. I'll share the recording